Good morning, guys. One of the weirdest patterns that's starting to become a thing in this thing that I'm doing is that I'm being suggested on TikTok, on YouTube, a lot of mathematical videos and visual videos because the algorithm is figuring out what I'm kind of interested in. And yesterday, as I was going to sleep, this guy turned out, Nils Berglund, and he's a mathematician who basically is doing all sorts of. I'm actually not even sure. Is this the same guy? Is there another guy? But he's doing these sorts of simulations a lot. Resonant modes, and this is basically pretty much what we have here. It's very much like the geometric neuron. The cavities are kind of like where we have these. Like if you look at his other stuff, these are kind of like dendrites. So the idea of the geometric neuron was initially that we get the soma is mixing Moiré patterns coming from downstream, I guess. Yeah, you could say. And this is doing exactly that. So that was a weird fever dream that I had. I don't know, a year back when I was thinking of this all. And here is a guy who is simulating similar things. Of course, how do you turn this into a computing entity? Well, yesterday I was talking about this stuff, and the day before, 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 and I have a ton of repos at GitHub. So, which a lot of them are just wild, completely crazy, nuts, and so forth. But the way I developed this is that I let AI take the lead, which is one of the things that happens there is that because they don't know everything I've done before, so they may go weird different ways. But like this morning, yesterday's stuff and some of the older repos, I gave them the Claude and we were developing this stuff. And this morning, I just thought here are the videos. This reminds me of the what we have been doing, and I asked it to develop. Can you make a geometric neuron based on this? And so the original geometric neuron that was complete accident was once again. Um, I'll show it to you guys once again. Was the accident in perception lab from last fall? Where perception lab was kind of like it was just it is very much pretty much like ComfyUI, graphical node thing where you can build nodes very easily. They are Python code and they are represented by these things you can draw and change. And so last fall, I was doing these nodes, crazy amounts of nodes, really completely out of it at times. And like all of these actually here are nodes that are being loaded. And basically, I was kind of like thinking, okay, visualizations, mathematics, not really understanding all of it very well. But so I had a coupler node, homeostatic coupler node. And I had, of course, somehow heard someplace that okay, neuron, it's a coupler, it's homeostatic thing. It tries to stay in homeostasis with its environment, and we had mathematically homeostatic thing that outputs numbers, inputs numbers, tries to stay kind of like in within a certain realm, and then this, I mean, how life can be so weird. I mean, like I connected it to a chessboard, like just connected it to chessboard. From chessboard, I connected the chessboard output to image to vector. So that chessboard pattern was turned into a number, and it had a like how long it is. That was sent to vector splitter. So that was, I guess you could say, would that be upsampling, downsampling? It would be like broken into, if you have 256 numbers, it was broken into subsamples of 16. And out of that, we sampled four top numbers and brought them back to the let's see, name. Brought them back to the coupler, and what we got accidentally was ECG, and that sent me on this whole quest. So ECG kind of like signal, and this is what many different AIs have now been thinking about. And so you can see the chessboard pattern, it's blinking, and what we have here is chess pattern. And all of these things matter. So this is actually the chessboard pattern that's coming. And the numbers matter, how this thing is wired. So we have, so this is kind of standing like here, it's not doing it at 1024, 2048. It's doing it once again, everything matters. So this is kind of like a neural membrane, and then I realized, okay, so we have geometry, we have signals, we get this steady beat at some settings, we don't at others. Here's the vector splitter, here's the image to vector. So this is basically adjusting the size of the checkerboard. And now I look at the Nils Berglund picture. If you guys think that you gave lots of these, and it's not a checkerboard, it's a Moire pattern, these are talking to each other. So the basic idea was that neuron, it has a soma, and the soma is filled with ion pumps, and it has a certain noise. This is called the Johnson-Nyquist noise, which currently I think it's being treated as just noise. It's noise, but what if that's information? And then there's the dendrite, which we are thinking is the Taken's cable function. So Taken's, it's a delay line. Dendrite is seen as delay line. But then the signal is coming into it. And this is something I'm just making, just kind of like talking to you guys as some kind of thinking, comparing it to the Berglund stuff. Okay, there's the, but anyway, so what if it was like this? So this is the Berglund video. So then this thing here, would this be a landing zone? Would this be kind of that? Because it's known that dendrite does processing where the action connects to the dendrite. There's like things matter, like if things come like 1, 2, 3, 4, like it connects like 1, 2, 3, 4 connection, it sends out a different signal towards the soma than if it's 4, 3, 2, 1. Like if you connect it, if we start building the action to this, and if you think about this Moire processing, then the problem becomes like this doesn't have the action initial segment. Action initial segment is where the neuron sends the signal forward. And it sends it at this ping that's super high. How would that work if we start wiring it in? Then I had this, and this is completely and utterly bad shit. Not really. Also, kind of relating to this, just by sheer luck, which was that I was thinking the action initial segment that has these grooves. Let's see. And once again, I have brain damage, so I should not be listened to seriously. But if I happen to be right, I want my Nobel Prize. But so, action initial segment has this grooves. So let's see. An action initial segment sets out the ping. Here's Lettier, who's been one of the leading scientists thinking about the action. So the action initial segment out of the, so here it is, that's sending the ping out, the fast ping. It has these grooves on it, these things, 190 nanometers apart. And this is actually what it's made of, microtubules. Penrose thinks that there's some sort of quantum calculations going on there. But so this is placed and it's gonna give the signal a slight phase. Now the phase is kind of the circularity that we see on the Berglunds, these things. What if the ping is sending out the Moire phase to the next unit, kind of like this? Although all of these would have the that thing. And then I was saying about the theta gamma. So the brain is processing data which is coming from medial septum, I think, or I think that's what it's called. So there's this clock on the brain, M septum. That's theta frequency, and then we also have things. Of course, there's from delta, from the low frequencies up to the high gamma. But then there's this network of neurons that are called chandelier neurons that connect just to the action initial segment of other neurons. They are basically they have a volt. Can this theta frequency processing neuron can it send out a ping or not? So there it's comparing, I guess, something. And this is actual thing too. Don't remember the name of those neurons, but comparator, I guess you would call that neuron. So what I'm starting to get this kind of like how it's this idea is mixing in my brain is that if this was solved, then we would have these Berglund things. We would have them at the theta frequency, of course, perhaps others. Then we would have them at gamma frequency. And if we would have the action initial segment, kind of a ping here, sending out the phase from this to the next one, the gamma frequency ones would connect to the ping, and they would be comparing somehow whatever is happening here to themselves and voting, are we allowed to this lower frequency neuron send out the signal? And what I'm starting to get here is that there's something called hippocampal loop, the cortical loop that goes from hippocampus towards cortex, and it's always going like this. So hippocampus has memories. Hippocampus, I was trying to think that hippocampus and this whole theta frequency neurons, they would be kind of a world model. And on the top of them, there is a faster system which is present that runs mainly in gamma. And I'm starting to think that that is the world currently. And it's resonating with the past in the brain. So it's the faster system is getting signal from the eyes, from the skin, and just by resonation. So it's like hooked up to the older thing. The older thing would be world model. Where have I been? Where have I seen this? And it would be resonating with past and the gating of the voting of the ping. Like can this signal propagate from the older thing forward? Would be kind of like the present moment having a vote on the past. Like does this resonate and so forth? Perhaps thinking whatever. Very getting very in phase. But boom. But so this is kind of the image I'm building of the geometric neuron based on this accident here, and the tons of repos that Claude and Gemini and so forth are making. They're interesting because they are computing, and I'm thinking about agency and stuff, and at the same time, because my capability to remember this stuff, because I can't really hold the mathematics, it's veering left and right, very kind of organically. If I could hold this mathematically, I guess I could write a PhD, try to explain this and somehow attach to it, but because I can't hold it mathematically in my brain, whatever thing I happen to see on YouTube, TikTok, the idea is kind of drifting left to right, and it's kind of like resonation-based cortical thing, and thinking about AI at the same time and other things, and but like for example, right now here as I'm looking at this thing, look at that, guys, how the ping is going from it's moving from left to right. It has a standing wave. Just that's very interesting. But in this theory, I guess, and I'm going to say things that are absolutely bad shit. If a scientist would be listening to me, they would be like, shut the fuck up. But anyway, so consciousness would be a standing wave, perhaps a little bit like this here. A thing that is living in a world model, which would be the perhaps the theta frequency based thinking in the brain, which is all of the past, and that would be like in the neurons if they are delayed cable lines, they're holding this past constantly. So present is coming in, it's talking to the past, and the past is helping these delay lines, so the dendrites and the somas and so forth. And there's this sparse coding going on there, kind of like here the signal it's correcting, like because like if you guys think about what's happening here, so this thing, this coupler that's standing for a neuron that wasn't supposed to even be that, it has a certain state. It tries to stay in homeostasis, but it's off balance. And how is it off balance? If we just make this a loop, if we just do this, turn this to a loop, like here it actually took off it had a steady value 1 against it, and it's starting to just do this like that. But if we just make it loop, we send the signal, nothing happens, it's dead. But when it's off balance, it starts to do this da-da, 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 da-da. Because the way it was set was that the signal, the way it propagates, it's never, it tries to match whatever it's sending out. But because the signal is broken, we're only sampling some of it, it has to add something to it. This would be, in the mainstream neuroscience, this would be just that the membrane is at certain level, and when it sends out the ping, the membrane electricity, it gets weaker, and because it's weaker, it has to pump it back up, and that's the basically the thing that the neuron is doing constantly. That's kind of the mainstream idea. And of course, that starts to then it starts to go to the world of the ion channels and the different neurotransmitters and all that. But so basically, complete accident. Yeah, last year with this thing here, and next thing you know, I'm modeling it. How close to neuron can I get? Just crazy idea. Here is actually another one that uses Hankel matrices, and so we actually here we actually have the attractor for the whole thing. Like we can, as we change the thing, we can see the we actually can capture the skew of time and so forth, and you can get as complex as you want with this. But the Nils Berglund ideas this morning were matching perhaps a little, and here we actually have Claude. As I was talking, it created this idea, and it was actually thinking by itself. So here is actually how it was thinking. So we have dendrite A, we have dendrite B, and they are coming to soma. Soma has the action, and this I will release as a repo, but I guess we can look at the code a little bit. Let's just so the heavy lifting here is being done by Claude. It's being done by AIs, and I can only imagine if you had Midas, how far we could go. Like that's kind of the thing that I was excited about, and of course, the thing happened that I guess would happen that AI becomes a thing that nations will basically not allow other nations to use it. It was happening, or it was going to happen all the time. I mean, it was clear as day. But let's actually put this to the GitHub. So so what was that called? It's called. So like here, I just gave the Berglund videos, some of the stuff I was thinking about last night, and Claude did the repo. I did not even look at it. I usually do not do it like this, but phos48 makes resonant neuron based on some visualizations of Nils Berglund, and that I saw on TikTok. Let's keep it as shady as possible. And let's say just compose my videos. The reason why I keep these ridiculous names of it and stuff, why I do not like try to be really academic, is because I sense I am not in a place where I should be doing that. Like I am not a scientist. The scientific method escapes me. I'm kind of coming at this kind of like a musician, or perhaps a shitty musician. With I get these bursts of excitement, dopamine in the morning, and I get excited, but then I get kind of like tired and I forget and drift, and it's not very scientific thing, but this has been my method now for quite a while. So resonator computer, working arithmetic unit built from Berglund geometry neurons, interference summas and threshold axons. Inspired by Nils Berglund's angled cavity resonator rings, a central cavity fed by skewed satellite cavities, this repo asks a sharp falsifiable question. Can a network of interference resonators with threshold actions actually compute? Not resonate prettily compute in the sense that a screensaver cannot. The proof is arithmetic. We build one neuron type, so a single unit computes XOR. And coincidentally, XOR is the thing they say that a human neuron can do and other animals cannot do. So there's neurons on the frontal lobe that can do this. Other animals don't have that, and it's one of those things that's been connected to the human special capability, which led to the language and so forth. And here, as I was talking bullshit, Claude developed a system perhaps that does that, based on TikTok videos and complete accident. This is kind of evolution in the front of your eyes. It just happened. Of course, we don't know did it work. We built one neuron type, so a single unit computes XOR. The function scholar McCulloch bits neuron probably cannot because it's not linearly separable. So McCulloch bits neuron is the neuron that was developed in the 40s by Coulomb and Bits, what the whole AI thing is based on. They very, very smart people who invented, they were looking at the point neuron and they developed that. And here we had AI just develop perhaps something. Compose units through action, so it's going to do that. Then write pings into a 1-bit full adder, chain those into an n-bit ripple carry adder, and add 1,000 random numbers. Every result is checked exactly with the real damped oscillator dynamics, not just the algebra. And here is the thing, and so you guys can go to this and check it out. And is it bullshit? Is it true? And how did this come to be? Okay, we had the accident, but there was things earlier steps. For example, the directionality of signal that these things can actually measure. That was kind of like it was a big thing. Fable played a part. Fable was not allowed to think about neurons, but I asked another AI to turn the whole geometric neuron idea into units. So it wasn't neurons. And of course, because this is pure theory, it's very easy. I mean, like, is it neuron? Is it reality or is it not? I can easily say it's not because most neuro scientists would agree it's not. It's bullshit. So I can just say that, well, take off the word neuron and say that these are units. And as units, when Fable was thinking about this, some, I don't know, could you call them breakthroughs happened, but that was one step. Like there was a wall I could not get through. I gave the system to Fable. Fable was chewing on it and figured out some things. And now the wall is U.S. government that does not allow people to use AI because it's a national interest thing. I think that I sense that we would come to a wall. But is this bullshit? Is it real? I don't know. I guess if you're a scientist in USA, you could float this by Midas 2, Antarctic, whatever, Where does it lead? Are we on the money? Or is neuron doing something like this? I don't know. But yeah, this is what I'm doing this morning, and as always, I hope you guys are well. Bye.